Google Argo Electrical Services, North Georgia's premier electrician. Call 770-596-1437 today.
Hello, I'm George with Argo Electrical Services. So today's podcast is on grounding in electrical systems. We're going to be touching on the definitions, Article 100 in the National Electrical Code. The four main types of groundings that we'll be touching on will be residential, commercial, industrial, and utility grounding. For clarification's sake, there are really four types that we'll be briefly discussing: residential, commercial, industrial, and utility grounding. Residential grounding systems protect people and pets from electrical shocks and electrical fires. Home grounding usually includes grounding rods connected to the service panel and using ground fault circuit interrupters, or GFCIs, in wet or moist locations. Commercial grounding protect against electrical hazards and ensure the continuity of service and maintain system stability. Sturdy grounding systems in commercial settings usually include multiple grounding electrodes and extensive bonding. Industrial grounding. In industrial settings, grounding is fundamental for the safety and functionality of powerful machines and high voltage electrical systems. Industrial grounding must adhere to strict wiring standards. Utility grounding is the implementing of electrical power lines and equipment to the earth, ground, through a singular conductor, creating a low resistance path for excess electricity to safely dissipate in case of a fault, thus preventing electrical shock hazards and potential damage to the system. So once again, most of the discussion will evolve from the National Electrical Code's definition, Article 100. First and foremost, I'd like to give a quick shout out to all the local, state, and other groups that conduct inspections in the electrical industry. Over the years, and I've been in the industry almost 40 years now, I've seen more electrical inspections failed over grounding than any other particular subject. The inspectors are very stringent when it comes to electrical grounding and implementation of said grounding. Anyway, if you master this, you should have no problem passing most of your inspections. Grounding and inspectors. As much as they can create stress within my mind, these groups and individuals maintain, for the most part, a standard that is recognized in the industry, in the field of real estate, and ultimately the courts of the United States. These inspectors ensure a level of craftsmanship. They verify an engineering process, and ultimately they provide documentation and peace of mind to the public. It may not always feel like these statements are true. However, that's my take on the process. Okay, so as an electrical contractor that has been in the industry for approximately 40 years now, I can say that I've been a part of and heard more failed inspections ever, the task of grounding, than any other portion of the inspector's checklist. Today, I mostly deal with residential electrical systems, but I have extensive knowledge and experience with commercial and industrial electrical grounding installations and applications. Grounding and bonding are essential for electrical safety to be achieved in any electrical system. So here are a few terms that we will include to shed some light on how grounding in the electrical system works. Also, we will dive into some practical explanations and hopefully dispel a few misconceptions. Definitions, Article 100. The National Electrical Code defines ground as earth. It defines ground fault as an unintentional electrically conductive connection between an ungrounded conductor of an electrical circuit in the normally non-current carrying conductors, metal enclosures, metal raceways, metal equipment, or earth. Ground fault circuit interrupter, a device intended for the protection of personnel that functions to de-energize a circuit or portion thereof within an established period of time when a ground fault current exceeds the values established for a Class A device. Class A ground fault circuit interrupters trip when the ground fault circuit current is 6 milliamps or higher, and do not trip when ground fault current is less than 4 milliamps. Beware of open neutrals and reverse phasing. Grounding connecting to the ground or conductive body that extends the ground connection. This is a neutral wire. Grounded, functionally grounded, a system that has an electrical ground reference for operational purposes and is not solidly grounded. A functionally grounded system is often connected to ground through an electronic means internal to an inverter or charge controller that provides ground fault protection. Examples of operational purposes for functionally grounded systems include ground fault circuit detection and performance-related issues for some power sources. Grounded solidly, connected to ground without inserting a resistor or an impedance device. Grounding conductor, a system or circuit conductor that is intentionally grounded. Although an equipment grounding conductor is grounded, it is not considered a grounded conductor. Grounding system, impedance grounded system, an electrical system that is grounded by intentionally connecting the system neutral point to ground through an impedance device. By the way, you can see at the bottom of these slides is at Argo Electrical. You can always Google that, or my phone number is 770-596-1437. All right, so the upcoming slide is grounding conductor, equipment grounding conductor, a conductive path that is part of an effective ground fault current path and connects normally to non-current carrying metal parts or equipment together and to the grounded system conductor or to the grounding electrode conductor or both. It is recognized that the equipment grounding conductor also performs bonding. There are multiple listings in the National Electrical Code where additional requirements are listed in specific installation instances. And anywhere where the code book tells you to refer to a different chart or section of the manual, you need to check it out. You need to read up on whatever it is that you are grounding to, because just depending on what your application is, there are many different rules. All right, and the final definition here: grounding conductor impedance grounding conductor is a conductor that connects the system neutral point to impedance device in an impedance grounded system. A grounding electrode, a conducting object through which a direct connection to earth is established. Thanks for checking out this short video. We'll be talking more on this discussion. I just wanted to spit these out to get a little content and, introduce myself. So again, my name is George. I'm with Argo Electrical Services. We're out of Gainesville, Georgia, Dawsonville, Georgia, Cumming, Georgia area. You're more than welcome to reach out to me at any time through this YouTube channel or through my phone number. Have a great day.